Hi everyone, thank you so much for coming to this lesson. So today we're going to be going over sequences. A lot of this is GCSE recap, but the learning objective is to be able to work with sequences and understand key definitions. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. So the first thing you need to know how to do is how to work out what the expression for the nth term of the sequence is. So let's say we have a sequence here, which is 5, 8, 11, 14, and 17, and you want to find out the nth term. The first thing you want to do is work out the difference between each term of the sequence. So to get 5 to 8, it would just be plus 3, 8 to 11 is plus 3. If you do 11 to 14, is that as well. So then you know that because you're plussing 3, then you'd have 3n in your sequence. And then what you can do is you can just work out what 3n is, with n being the position of your term in the sequence. So your 3n's would be, so for the first position, n is 1, so that would be 3. Second one would be 6. Third one would be 9, and the fourth one would be 12. And then you need to know would you get from your 3n to the term in your sequence. And just to get to 3 to 5, you just add 2. 6 to 8, you add 2. So then the nth term expression would just be 3n plus 2. And then they can ask from here, what would the 50th term in the sequence be? So if you want to try that out for yourself, but what you would do is you would just plug in for the 50th term, you would just plug in n equals 50 into your expression here. So you would get 3 times 50 plus 2, which is just 150 plus 2, so it's just 152. And that would be the 50th term in your sequence. So that's how you use that's how you find the nth term of your sequence, and how you can use that to find a specific position, a specific term in your sequence. So another notation which you need to know for sequences is to do with recurrence relationships. So recurrence relationships is just when you have, if you want to try and find out what the n plus 1 term of the sequence be, using what the nth term of your sequence is. So like for example, how to get from 8 from 5 or from 11 to 8. And the notation we have here is n is always the position in the sequence. So let's say you wanted to find out what the recurrence relationship of this sequence is. You know that you just have to add 3 to get to the next term in your sequence. So un plus 1 would just be equal to the term before it in the sequence. So if we're going from 5 to 8, so un plus 1 is 8, and un is the term before that, so it's 5. You just have to add 3, so it'll be un plus 3. But that's not all you have to do, because this is not representing what this whole sequence could be, because un plus 1 equals un plus 3. That could be any sequence. It could be like a 50, 53, 56, etc. We need to specify what the first term in your sequence is. So then you could just specify u1. So n is like the term, the position in your sequence. So the first position in the sequence, that's just 5. So that's how you write a recurrence relationship. So the next thing you need to know is some key definitions. So I've written out the 3 ones we have here. So we have an increasing sequence, and that's just when each term is larger than the previous term. So if we were to write this in a more mathematical notation, like using what un's and un's plus 1, with n being like the nth term in the sequence, you could just write that as being un plus 1 is greater than un, because every term is larger than its previous term. So the next one you have is decreasing sequences. So that's when each term is smaller than the previous term. So if we were again to write this out using mathematical notation, that would just be un plus 1 is less than un, because you have each term in your sequence is just less than the term before that. So if n was 5, you would have un plus 1. So the sixth term in your sequence is less than n equals 5, the fifth term in your sequence. And then the last one we have is a periodic sequence. So that's when you have terms in your sequence repeating in a cycle. So it could be a sequence that's just like 0, 1, 2, and then we start again, we have 0, 1, 2, and it just continues in that sequence forever. So that's what a periodic sequence is. So we have an exam style question here, and so feel free to pause the video and try it out for yourself. So we have a sequence has nth term 7n minus 16, and we want to show that this sequence is increasing. So the first step we want to do is we want to write this out mathematically using the un notation we learnt. So that will be, so we can just write un is equal to 7n minus 16. Because n is just the nth term, so that's how you can write out the nth term of sequence. And then we want to show that the sequence is increasing. So all we want to show is using this definition, we want to show that un plus 1 is greater than un. So to do this, we want to figure out what un plus 1 is. So un plus 1, to do that, we can just sub in n plus 1 as n. So you just do 7n plus 1 minus 16. Then if we simplify that, that's just 7n plus 7 minus 16, which is just 7n minus 9. So now we just want to show that 7n minus 9 is greater than 7n minus 16. So 7n minus 9 is obviously greater than 7n minus 16 because you're subtracting a larger number away from 7n than you are over here. So that means therefore un plus 1 is greater than un, so therefore it's increasing, so therefore the sequence is increasing. So that's how you can, so if you haven't, if they've given you a sequence in terms of the nth term, and they want to show you, they want you to show that's increasing, you just want to figure out what the un plus 1 is, and then you want to show using these definitions here that un plus 1 is greater than un, and if you want to show it's increasing, you want to show that un plus 1 is less than un. So the last thing you want to know is just the difference between a sequence and a series. So a sequence is just a list of numbers that follow a certain pattern. So it could just be like 2, 4, 6, 8. So that's just they're just increasing by 2. So that's just what a sequence is. And then a series is just when you add all the terms together to find a total. So a series would just be like 2 plus 4 plus 6 plus 8. And so there's another notation that you could use when you to find what the series is. So let's say you have a sequence. So firstly, let's say you have a sequence with un is just equal to 2n plus 1, let's say, so like a random sequence. Then if you want to find the series, that to write the notation for that, you use this term here, which is also called the sigma notation, and then you just write the sum of 2n plus 1. And then if you want to specify the terms that you want to add up between, you just write your numbers in the bottom, like below it and above it. So let's say you wanted to do it from the first term in the sequence, you just write from when n is equal to 1. If you want to sum that up to the 100th term in your sequence, that you just write n equals 100 at the top. And that's just a brief overview of the difference between sequences and series are. Following videos, we're going to be. So thank you everyone, hopefully this was useful. So this was just a brief overview of sequences and understanding some definitions that you need to know. So this will just lay the foundations for coming videos that we cover, which will be about both arithmetic and geometric sequences and series. So yeah, again, this may seem a bit simple and just a recap of GCSE, but it's just so you have the foundations for what's coming next.